Hello, welcome to this video where we're talking about how to aim the gun. So this is a bit of a dev blog on how the gun aiming used to be done and some of the issues I found and some of the things I changed to fix them. We've set up an aim offset for this character that has a horizontal axis for the yaw and the vertical axis for the pitch. And all of the various animations are set up in the appropriate place to make you move forwards, backwards, left or right. You're holding the control key, you can test that out. You can see that you can point the gun in all the directions. It's the responsibility of the animation blueprint to pass in the values for that pitch and yaw to make sure that the gun points where you want it to. Here you can see the animation blueprint for this robot character. We look at the locomotion armed and double click on the walk run. You can see that we're using a walk run armed blend space. If you double click on that, you can see that we're using the direction and the speed to control the animations here. And various animations to show whether you're moving forwards, left or right. In the event graph for the animation blueprint, you can see that in the update event, we're going down, we're doing a variety of things, but right down here at the bottom, it calls this node, which is called calculate yaw pitch. It does some checks to see whether you're in the ladder or ledge climbing or sliding down a ladder. If you are, it just sets the pitch offset and the yaw offset to 0. Otherwise, you can then grab it from the player character and then it sort of sets that onto the actor's rotation. And it also caps the value so that you're never bending over backwards or forwards too far. And then you eventually set the yaw and the pitch. The next thing to look at for this is the gun itself, which here I've got called tool_SMG11. So we've got the skeletal mesh of the gun itself, and I've got a gun laser object and a target point object, which is this white ball. Now the gun laser doesn't have any function apart from being useful for debugging, so that's normally invisible. The white ball is also normally invisible, but it does have some logic used in the get bullet target function. So in this one, we do a line trace from the muzzle flash area of the gun, and we go forwards 5,000. And then if we get a hit, we set the relative location of the target point, so that white ball, to be that. Otherwise, we just set it to be 2,000 away from the gun, but along the line of the gun laser. And then we return the where that white ball is, but also the origin point, which is the muzzle of the gun. The final key piece is the adjust aim offset that's in the third person character. So this is ultimately what will be used by the animation blueprint to control the pitch and the yaw. So here we just check that the gun is valid. Then we call the get bullet target to function that we just looked at. And then from there, we can basically work out the X and Y coordinates of where that white ball is. And we can also work out from the get viewport size divided by 2, the X and Y coordinates of the reticle, which is exactly the center of the screen. Then basically we got some clamping and multiplications to control how much you move per frame. And you could basically either move up or down, left or right, depending on whether the white ball is to the left or to the right or below or above the reticle. And after you move a certain amount, which can be clamped so that you don't move too much, it then sets the aiming pitch offset and the aiming yaw offset, which is then used by the animation blueprint. So here's the basic shooting system. The laser turned on and also the white ball showing, which tries to be where your center screen reticle is. You can see it basically works fine. You move around and it follows the reticle, tries to always shoot where you're firing. But there are a few issues which I'm going to go through and then talk about the fixes of those. The first issue is that when you crouch down and aim at a wall, you seem to be aiming too low, and it seems that it won't go up to the reticle and is always aiming a little bit on the low side. The fix to this one was relatively simple because I'd actually clamped the minimum of -33 in the adjust aim and offset function. So if we change that to -50 and have a retry, now if we crouch down, you can see that the aiming pitch offset is now changing to -40, -50, but it's still not quite on the reticle. So I'll try changing this to -80, then just compare the results of that. So now if we crouch down, you can see printing to the screen, we're getting -40 there, -40. So that seems to be enough actually most of the time. Just sort of dipping above 50 there. So it looks like we've got what we need now. And you can see now that the ball and the laser will fire in the correct place so that it hits the reticle. The next issue to solve is the one that where if you jump, it takes a very long time for the gun to get back to the target. See if we fire, look, it's a good sort of 3 or 4 seconds before you get back there. Obviously that needs to be speeded up a bit. The other major issue I've got is when you aim just at the edge of a wall, you start to get oscillations because as the reticle moves off the wall, it tries to move you back to the left again, which then moves the ball onto the wall, which then makes you try and move to the right. So you end up with this sort of thing oscillating backwards and forwards. And it's even worse if you fire just over an edge because you get the oscillations this time up and down instead of left or right. The fix to the jumping was relatively simple. I just needed to increase the amount that you could move per frame, which before was only 0.1, clamped at a maximum of 20. So now I've gone up 10 times faster and a maximum of 5 times more, which you can move per frame. The results of this are that now when you jump, it does snap back nice and quickly. As soon as you land, it snaps back. But the problem is, although the jumping's a lot better now, when we do the edge clipping against walls, we now reverberate a lot more, and that situation is now terrible. So obviously needs fixing. My first attempt to fix this oscillating was to add a second target point along the line of the gun laser. I made the ball red. And then in the get bullet target function, I've added in an extra sphere trace, and then I set the target point 2, which is the new red sphere, to be that position, and then I return both the original line target point, the origin point, and the new sphere target point. And now in the adjust aim and offset function, we can compare the distance between the two balls. And we can say if it's, say, less than 50, we can do a branch in the code. And basically, we only do the aiming if the balls are that close together. If they're a long way apart, which is what happens on some of the edges, then the aiming briefly gets turned off. You can see now we don't get the oscillations against the wall. It at first glance seems like it's an okay fix. As we start to aim around the corner, we are sort of pointing off towards the right rather than sort of trying to aim through the wall at the reticle, which is what PUBG does, which we'll have a look at later. But you can see it's at least it stops the reverberations. So the major flaw with this double sphere approach is that if you're just aiming above a block like this, it's turning off your yaw and your pitch. And here you'd actually want to be able to still move your yaw left and right. But also here you think that you're aiming at the second guy over from the left, but then you actually hit the third guy over from the left. So I replaced the second sphere and sphere collider with 2 box colliders and 2 rectangles that are for the vertical and horizontal. So now it can just turn off either the yaw or the pitch, depending on which way it's going. Here you can see that the boxes are just a guide because they do actually twist slightly as you move up and down, but you can see that the box colliders the vertical and the horizontal one, they always stay level with the ground. So the plus shape of the two rectangles is just a guide. You can see that as you move, they can separate out. So here, like the vertical one is hitting the wall at the front, but the horizontal one is hitting the top of the wall. If they get too far apart, we turn off the aiming to stop the oscillations in that direction. Okay, let's have a look at the results now then with this turned on. So you can see that at this point it's setting the pitch and yaw, so shoots where you would expect. And if we move behind this wall and we go to the right, you can see that the red dot appears showing where we're actually aiming. And now we're just setting the pitch, so we can move up and down, but we won't go left to create that sort of wobbling around. And then when we go back onto the wall, we are now setting the pitch and yaw again. And then if we run up and crouch down, get something similar. Here we're just setting the yaw now, so it's showing the red dot because we're setting yaw but not pitch. So it's not ideal. It's a bit weird that you get the red dot in addition to the reticle at the center of the screen. I think it would be nice to actually make further improvements to this and solve it in a different way. Next, I took a closer look at how PUBG does the sort of edge case handling. So you can see here, you can just about hit the silver board. If you move over and try and hit one of the darker boards, you hit the pillar, as you'd expect. Then as you move further left, you hit the pillar. You can see that as the reticle moves to the right to the impossible bit, the bullets start to hit lower on the pillar, but the gun doesn't actually move downwards. Looks like they're drawing a line trace from the nozzle to the reticle rather than a line trace in the direction that the gun is pointing. The other feature you can see in PUBG is if you hold in the right mouse button, you can make a little red circle appear to show that what you're aiming for is actually impossible. Okay, now we've got the next iteration of this. So instead of always using the XY coordinates of the reticle, we're now doing a trace from the camera to the reticle and then a trace from the nozzle of the gun to the world position of the reticle. And then if that trace hits something, we then try and move the ball and point the gun towards that point instead of the reticle itself. So if we're just aiming at this wall, see it's just aiming at the wall as normal, but then when we go to the aim at the impossible part, we now get the little red dot and we're now aiming at that instead. And you can see if we start aiming at some of these, you can see that we cannot shoot that one. If I fire now, it hits the wall as you'd expect because you've got the red dot warning, just like you see in PUBG. And we move over to that one, and then you can see that the firing does work there. And also if we go up and crouch down, just to check we've got the same, so the same happens with the pitch. If we try and shoot these from there, we go over the top. Or if we try and aim at them from too close up, you get the red dot to indicate that you can't fire over that. I still had to have the box colliders because you still got the juddering when you just moved from this point to the point above. But now all that juddering seems to have gone. You sort of get the expected results basically. I added in a new function called get target screen XY for this. You see that we do a trace from the camera first, so you can do the get player controller, deproject to world, then you do the viewport size and you get the X and Y coordinates for that to plug into that. Then we can do a really big long trace, you ignore yourself so you never hit your own mesh. And if we get out a hit location, we can go on to trace from the gun to the reticle. If we don't get a hit, then we can go straight down and just use the reticle as we did before. But if we did get a hit, then we do the other line trace. And then in theory, then we hit something closer like a wall. And instead, we get the x and y coordinates of that wall to return from this function instead. Otherwise, we fall back and use the reticle. I'm also returning a boolean to see whether or not you're hitting the reticle, and that's basically done if the total distance between the 2 points is less than 10, and that can be used to show or hide the red dots from the by the calling function. That's the end of this video. I hope it was useful. Please like and subscribe. It will really help out the channel, and I hope to see you again soon.